So a little bit about Build a Green. A lot of you probably have heard of us through the Greenpoint Rated program, which is not, sorry, I'm hearing a fly, I'm distracted, which is a residential green building certification program that we started back in the early 2000s. And okay, sorry, I'm still distracted by the fly. But what has happened is that the green building standards have got to normalize by that point. And Build a Green wants to consistently be pushing at that innovation forefront. So we went back to our roots to see like what was the key value we were bringing to the space. And the key value we were bringing was bringing in a diverse range of stakeholders to work together to work through intersectional issues. So presently, we are still convening stakeholders, but at the intersection of sustainability, affordable housing, and equity, with home as the connecting tissue throughout all of that. So just giving that. So one of the projects that we're working on is the Power Group. So the acronym is standing for Panel Optimization Work and Electrical Reassessment. The reason it came through that was I just want to use power because that was used all the time, and I just made the acronym fit that. But it is a group of a wide range of stakeholders from cities, utilities, nonprofits, policy, a lot of different people. It's a very open door policy, and they come together to share and discuss everything that's connected to electrical panel in the context of electrification for decarbonization. But it centers around the electrical panel because it seems to be the crux of a point of like how do you get past this to do everything else in a simple way. So we convened this group, and it meets monthly on the second Friday. So feel free to, if you want to drop by, just reach out to me afterwards. But I keep forgetting it's that side. Thank you. Okay, I'm like not, but so I'm gonna skip past a lot of the stuff because I have a feeling a lot of people here are very familiarized with like what's happening in the home. If you're not, give me a signal and I'll go over this. Okay, cool. So we have the electrical panel in the homes is where the electricity is coming through. And then it controls your power capacity, and that's why we're concerned about it, because there is a limited amount that it is capable of handling at the point in which the house is converted. Please do not like correct me on that. It's like seeing Sean like reading it thoroughly. So I'm going past this pretty quickly. Okay, so for a survey, I'm very curious about, for single family homes, like what would the panel size be that you think will be good enough for a full electrification for that house? So this is like an interactive thing. I'm very curious. For A, 60 amps. Anyone thinking say that? Okay, cool. B, 100 amps. 1, 2, 3, 4, 5, 6, 7, 8. 13. No, I'm just very curious. This is just a very general thing. C, 200 amps. 4, 5, 6, 7. Okay, 7. D, 400 amps. Oh, at least I'm very glad that you guys didn't go from A or D.
I want to say C.
You want to say C? Go for it. Thank you. So it is a very context-specific answer. For a majority of the homes, you can probably do 100 amps, but it requires a lot of planning and all this other stuff, which I'll get into. But there's also cases in which 200 amps, okay, Sean is not looking at me, it may be needed at times. So it's a very context-specific conversation. So just giving terminology of like what we use to describe some of the issues in our group is that when we're talking about replacing a panel with a higher capacity one, in our group we usually reference it as panel upsizing versus panel upgrades, because it seems like, if you upgrade the panel, you get a lot more different, like, it's more powered up, right? Like it has better benefits, but that's not always the case. So the group likes to refer to upsizing because that's just really specific for increasing the capacity of the panel. Because you can do a panel upgrade and you can still like put it like same capacity, but it's just like, a much more modern version. It's safe, it's not gonna blow up on you, all that kind of features. So throughout the presentation, I'll be using upsizing more, just to reference so you know that the panel is gonna be increasing capacity from what it was pre-project. So, can I go back? Oh, so very curious, another survey. So how much we think it would cost to upsize a panel? So basically, increasing it from what was the current one to a higher one. Would it be A, $500? Okay, great, you guys are really good. B, $3,000. This is where it's gonna get interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, C, $10,000. 1, 2, 3, 4, 5, 6, 7. 7. And D, $30,000. Okay, so I'm gonna give the answer like ahead of time. So it's a range, actually, from B to D. And I can go into the more specifics on that. If I don't, did it go past? If I don't, please get back. Please let me know. But there is very specific reasons why the cost for certain homes will go up to $30,000. And those are situations that have happened. For the person that wants to know specific pilot programs, Sean has done it for his group and his team, so you guys can go into specifics on that. So for why would you need a higher capacity panel, or why would you make sure that the panel capacity is sufficient enough, is that you're going to be transitioning homes. And I think you guys have all covered that. You will be replacing your fossil fuel appliances. They're usually your water heater, HVAC system, your cook stove, and replacing with electrical version. You're also going to be adding increased load onto your home by adding solar, battery, and EV charger that's a level 2 and above. Distinguishing that because level 1 doesn't make a difference, but it's level 2 and above that makes a difference. So the answer that I gave earlier is like, usually you do not need to upsize your electrical panel. Like most electrical panels, I think general consensus in the power group, I say this because there's a very diverse range of stakeholders that have very different opinions. But general consensus is that majority of homes has sufficient panel capacity at 100 amps to electrify, depending on certain contingencies. The longer answer is it really does depend by home, given the feasibility and technical assessments, because if you have some panel capacities that are 40 amps or 60 amps, it's going to be very difficult, depending on like what's the usage, how their behavior is, like all of that. There could be constraints on the panel space, and I think some of you have brought it up. If the circuit breakers are all used, you will probably have to replace it, because if you're adding more appliances that have different loads, so just like how was the circuits installed or the bus bars installed on the panel during the renovations time or when the house was built. Did I get all correct? And also if the panels are older or unsafe, because there are certain panels that have known safety issues that should be replaced. And so those are situations in which you would want to make sure to replace the panels or upsize the panels. So the interesting part, this is like data that was pulled from Home Energy Intel, HEA, for that. Home Energy Analytics. Darn it. Okay, Home Energy Analytics that worked with worked with PG&E for seeing if their customers would electrify their homes. So they provide like a dashboard, interactive dashboard, and they actually collect energy usage data as well of before and after of what was the capacity and like use capacity of the panels. So this has been passed around. I think if you guys are on a decarb listserv, you guys have seen this.
I haven't seen it. That's great.
I thought you've seen it. I thought I've seen you pass it around. Oh, you've seen it. I know you've seen it. So what it shows is like for the blue lines, that's the use capacity of the panel. So that's actually the usage of the panel at the time. And the red data is just like, this is how much panel capacity that panel can actually go for. So this is like, 100 amps. You can see like a lot of the 100 amps, the use capacity is below. So if you look at where the use capacity is for the blue bars, a lot of them has remained below 100 amps. So this is data from 81 homes on that point.
I have never heard of a 300 amp panel. Is this a
You should, because tech has actually incentivized, I think. There are like 340 amp panels for your heat pump incentive program for the tech one. Like we were like finding it interesting. We were pulling out like, oh, some people have got up to 300 amps, 400 amps. There were a number of them. So yes.
Okay. Also, there is sometimes there is a difference between a 200 and 225.
Yeah.
So there is nothing for 225. So I mean, usually is it same as 200 amp?
I don't know. So if you give me your contact, or like just connect with me, and I'll connect with you with the person that has the data, because I have not dived into the data. This data has come up like within the power group because everyone's coming from different research or different projects, and they'll be sharing the data that they have done or the research analysis they have done. And so this is one of the pieces of data. Another piece that was just done recently was with the tech data of like what was happening with the panel upgrades with the HVAC replacements on that. So, okay. I was going to say is like just know that this was done per 220.887 NEC code, just FYI standards for people who are interested. Okay,
is that the method where you look at the amount of energy that was consumed, or is the method where you look at the number of appliances that were in the place?
I think they measured the actual energy usage.
That looks like consumed. Yeah,
right?
like that's the peak. The blue is the peak consumed. Okay. I think it's interesting. The far right-hand side, the biggest of the houses that uses hardly any energy.
Yeah,
like the blue is the smallest of
but
them.
if they were to like, if they were doing it at the 220.83 when they were sizing it instead of the 220.87, because that's the conversation you guys keep having, that's one of the.
So does the red represent what
The
they
panel is.
decided to put in?
Yeah, that's the actual panel size at that home.
That they decided to put in?
Yeah. And then the blue is what they actually used at that house. Yeah.
Before they,
Uh-huh.
is it what they used after they put it in, or what they're using before they?
If you let me give you my card, ask me, I'll connect you to Steve, because he can answer the questions in much more detail in that sense. I'm very glad I did not bring the LB&L data set. That would be so interesting. So to the cost thing. So the cost is usually a typical panel size. If you would be upsizing just for the actual like panel itself, usually will only cost around like $200 to $4,500. I think that's like the average amount of cost. And that cost is borne by the homeowners themselves. Like they are the ones that are paying for that, right? And but this is not accounting for if there's anything else in the house, right? That because you're updating the panel, like whether you're rewiring it, recircuiting it, or like moving the panels because where the code was saying that is now unsafe due to code to have it this many feet away from the gas heater. Is that what it is?
You can have the panels moved because it's too close to a window or to a vent or to and every year the PG&E will change the rules on why you have to move it, so there's no knowing it. You just find out when they come.
So those are like the interesting like code related stuff like that will increase the cost of your project. But the service size, so the service is like to the house, it's the electrical, like service line that is providing electricity from the utility side that goes into, like the telephone pole, that pole top transformer that is delivered to your house. So if that needs to be replaced, it is dependent on whether it's the homeowners or the utilities. Sometimes it's both, and other times a lot of it may also fall on the homeowners if they were, I think the last one on their line connected to the transformer that is triggering it and wasn't anyone else on the line. But if it's like several of them on the same line, then the utilities will also help pay for it. There's a utility person here, so you can actually answer that in more detail. But it's different depending on the utilities and exactly where some of the transformers are located. Because some transformers in, especially in like rural areas, only 1 or 2 homes are connected per transformer just because of the distance between homes. So that cost is going to be much more like high in those areas. And then this also increased cost is usually the highest is because it is a pad mounted transformer. So there will be underground wire lines instead. So it's like the trenching, all of that. So if that is the case, that the increased cost is high. If it's more of like the pole top, it's a little bit of a, it's not as significantly expensive compared to the pad mounted. Also, time cost. So if you were to increase it, they're like, at least for just the panel, you would have a delay of like days or weeks, right? Depending on the permits, utility sign off, it's like a very simple process. But if you have service upsizing, there has been instances in which it goes from weeks to several months long. And I'm not sure what's the longest time I've heard, but I know it's like, we've heard
So
like.
18 months.
Oh, really? 18 months? Okay, there you go. So that is because for the longest lead time, it's not just the underground, but you have to get the utilities engineers on site to kind of scope it. Then they have to go back, do the analysis, then go back, do the permitting. So like that is where like some of the timing costs. So like trying to avoid all of this is usually much more helpful, but just like this is what happens if you were to go in that direction. So, oh, is it? I think. Thank you. So a lot of other things that a number of you mentioned is the other impacts is that we have limited resources. So you need those resources. It's not just to be going to electrical panels. If you can avoid it, like just avoid the necessary, you can have those resources stretched to do more things for the electrification, including assisting with the appliances, weatherizing the home, energy efficiency measures, and all of that. But if you were to put that as a package deal, it's like this is the normalized way of electrifying a house, you're going to have to upsize the panel, then there might be a potential waste for like millions of dollars, but also goodwill and all of that. So you need a lot of money because like from the costs I've shared with you, like if you were to do it as a per capita, there's not going to be enough homes that it would be significantly impacting. And I think for the IRA home energy, it's only $600 million, and that is like a drop in the bucket for what is needed for like all the homes. So we don't have the money to be kind of like spending it specifically on panels that doesn't all need to be upsized if you are able to do it in a thoughtful manner. Other things is that you also need the resources for health and safety, structural issues as well. So it's like there is just limited amount of money. So it's like how can we do that? Use it strategically is a question. We covered workforce in the earlier presentation, so thank you. I don't have to go over that. The other parts is the other interesting thing is that so you're going to be updating homes, and this is where you. In our group, we're only talking about existing homes. So these aren't new homes. This is just about like existing homes, right? If you're updating the panels, you're updating anything in the homes, there could be impacts on renters and tenants as well. Because some of them may be worried that because of the upgrade improvements in their homes, they can actually be pushed out of their homes because they can get a much higher rent for the owners because they have improved facilities. So that is another concern that has been expressed by focus groups about renters and electrification improvements. So just like FYI on that. Next slide, because I can't make it work. Okay, so how do you electrify without upgrades? So there's several ways. Again, it was covered earlier, so I won't go into too many details for some of it, but you can go to the next one. So one is installing power efficient appliances. So there's a difference between power efficient, energy efficient appliances. Like I think you guys all realize it's like for energy efficient, it's the amount of energy use in a duration of time. For power efficient, you don't want it to draw a huge surge of power at a high, like at one instant in time, because that would trip the electrical panel and increase the capacity. So there are power efficient appliances. And there's a very nice diagram on that side that shows like differences on it. I won't go into too many details, but some of it could be the 120 volt appliances that has been talked about earlier. You can also have increased water tanks for heat pumps, so then you'll have enough water without having to instantaneously having to heat up like a short amount or a small amount of water in a short amount of time. You can also install combi devices, so just devices that do more than one function. So you don't need to have multiple devices in the home. So there's like a washer and dryer combo, water and space heating combo, having a stovetop and an oven together, things like that. You can do low power EV charging, so just using the regular plug that comes with the electrical vehicle that can just plug into your 120 volt like outlet like the ones in this room. Or there are level 2 chargers that are also adjustable that doesn't actually always draw the peak load. Other things that has been talked about and shared is that you taking all of that like from the previous slide, also just being thoughtful about the electrification planning, because not all homeowners or people who live in their homes are going to renovate their entire homes all at once, right? Usually, sometimes you do it in stages. So making sure to plan that as well, of like making sure it's like, okay, that when we are installing this, you're not taking the circuiting is done correctly, or what kind of appliances to select and things like that. So just like strategically kind of like planning out like what's going to be happening in your house. And also weatherization is added into there, because if your home is sealed properly, then you wouldn't have to have such a huge like HVAC system to heat or cool your home. So that's also added. And then technology and gadgets, I think that was covered really well, like in the earlier, like several people have covered it. So I won't go into too many, but you can use smart circuit breakers, load switches, circuit sharing and pausing, smart panels and sub panels, and meter collars. And there are other meter collars on the market. I'll just touch base on that. That is not just utilities that are also trying to be able to have like solar panels or EV chargers on them. And the interesting thing is whether it's accepted by the utilities or not. That is basically the crux point of the meter collars, is if the utilities are comfortable with having that installed on the house. Because what happens is that it's installed past the panel, so that's where the draw is coming from, is because it's installed past the panel and it's not being managed by the panel. So if your panel is over capacity, it's like, okay, you're reaching the point, you can install the meter collar, and that is the point in which you're drawing the energy from, is from the meter collar. And finish my presentation. Thank you. I do want to give a huge shout out to the people in the power group. So if you go to the next 2 slides, these are the members in the group. So there are this slide, then the next slide. So there's like a lot of different members. It's kind of continuing to add people and growing. And it's just basically just sharing information, working with each other, collaborating, and just holding that space so you guys can have that time and focus and just connection space on that area. But all of the things I've shared are the things that have been coming up in our conversations. And these are the key things that there has been a consensus on. And I say this with like that highlight because there's a number of areas in which I can go back and point to, in which I can give you different opinions from different points of the group of what they feel is best to move forward with on that end. So on that, does anyone have any questions? Because I can go back and give you the different opinions, because I think that would be of interest. But if not, you guys know where to find me. Yeah?
So you are saying that a 2,000 square feet home can be electrified using a 100 amp panel. Is that true? Yeah, is that true for the new construction as well?
I think the new construction, the minimum is 200 amp panels. Oh. So you don't have to worry about for new construction. That's already like standardized. Okay.
So with data support, if I only want to do a 100 panel upgrade and you're doing rehab at a house, you're doing other work, maybe some energy efficiency, maybe some home repair, would it make sense just to do 100 amps stay there, cost savings, and then maybe use smart technology over there?
You can, like, it's kind of like dependent. This is where I say it's depending on which members you talk to. So I'm gonna give you both sides. One is that it can be very feasible to be able to keep within a 100 amp panel and add all the electrification measures. But you would have to, like for some of it, like you may not be able to like run like the dryer at the same time you're cooking, because those are two high energy intensive activities. If you're a household like that, then like if you're okay to separate that, then that's fine. But if you're a household that needs that, like there could be some people who the only times they're home are in the middle of the night, right? And they have to do everything at the same time. So it's very dependent on that person's behavior and the tenant's behavior on that area. So it's like, that's where it's like harder to say like prescriptive you should or should not. That's why I'm balancing that. Like Sean's like grinning because he wants me to go to the other direction. And I'm just like, it's dependent. But the other thing that's interesting is also like, if you're putting it on from a neighborhood or utility or policymaker, that's like where the impacts kind of gets magnified if you go above 100 amps. Because the impacts onto the grid, it's like who's gonna bear that cost? Because you have to upgrade the infrastructure of the grid at that point. If almost everyone is gonna be increasing like their panel capacity to 200 amps, that may not be helpful. Some of the technologies hopefully is gonna be, probably will go down into like normal cost of everyday appliances. At the moment, it's like still innovative right now, except for the smart switches. I think that's the cheapest one, but there has been like conversations like the span panel is a smart panel, but that is several $1,000s that may not be within the budget of some people. So it's like very dependent on like who the owner, what their project budget is, what they can move forward with. You can add into this, John. This is like a conversation. I said I was going to make this a conversation.
It's your presentation. I'm so excited about this topic also, though. So I'll just say that we've studied it, and we've gotten 3,000 square foot homes on 100 amps. And what we saw there is that the 400 amp panel that was up there had some of the least of the peak loads of all the houses of the 81 that you showed. Mm-hmm. So I don't really see a limit on the number of square feet if you have a load balancing panel, because it seems like in the real world, people don't use more than even 50 amps. Most of those homes didn't even get up to 50.
There's going to be like some data that I think the members are sharing that they're going to be coming from some research projects, especially from the CalNext projects, within a few areas in the disadvantaged communities in which they're measuring the actual usage, energy usage in those communities. So that one is going to be coming within the next half a year to a year. And then there's other research happening by both UCLA and the Lawrence Berkeley National Laboratory, in which they are evaluating what is the distribution of panels sizes across California. And for the LBNL study, that's nationwide, because they are doing it nationwide, if I remember accurately, but I'm not quite sure. So please don't quote me on that. So that is also coming out within the next few months as well. Any other questions?
Come get her afterwards. Oh, go ahead.
Well, this might be elementary for some of you here, but I would love the little primer on ampage, volts, power.
That's why I created the primer in the earlier part.
I was like trying to jot down notes, and you're like, you guys know this.
Because it was like so technical. I was like, let me go past this, because I kind of made it, okay, if you want to go back to the really earlier stages.
Thank
you. I created this because I was going into this without an engineering background. So I just absorbed it, kind of understood it, and then I updated it. So the power is basically, if you think of it as like the flow rate of the electrical current into your home. And it's usually measured in watts, and that is basically volts times amps. So basically that's what it is. So you may hear, like the easiest way to think about it is like if you were to think about it like with as a water analogy on that end. I can't read my thing, but
It's like the flow rate of water.
yeah, it's like the flow rate of water. So how fast like you will go. Like the energy is basically like the amount of water that is going to accumulate over a specific period of time. The power is just the rate of that water flow. So why we're talking about like panel capacity is that it determines the size of that hose. Like if you have a wider hose, you're going to have more power flowing into your home. So this one, I know that it's not technically correct because I remember like one of your members said it, but it's technically enough that it's okay in other crowds besides this crowd. But usually they reference the amps because that's the one that changes most often. So that is what it is.
Jasmine, we're gonna like hang out for a while.
Cool.
It takes all of us have gone through classes, like multiple classes, to get our heads wrapped around amperage versus voltage. And
I wish I had this data, but I was through into like managing you guys without like this data. I was just like, oh, okay. I'm like, I understand this general trend that you guys are talking about.
And you get billed for, when you get billed for water, you get billed for a number of gallons. When you get billed for most people, for home use, you get billed for kilowatt hours. So that's why this analogy is accurate.
Oh, thank you. I feel like I'm at time, right?
you are at time.
Oh, perfect.
All right.
Thank you.